Good morning, guys. Today we're going to continue section 2.2, polynomial functions of higher degree. Go ahead and take out your notes. I'll give you a few seconds. Okay. Yesterday we went through the different types of polynomial functions of constant, linear, quadratic, cubic, quartic, and quintic. Remember that a polynomial function is determined by the degree of the function, which is your highest exponent. That determines what type of function it's going to be. We also talked about the graph and how the graph is continuous with no breaks, no holes, or gaps. The curves are smooth and rounded, not sharp. Okay, let's talk about the end behavior. The leading coefficient determines the orientation of the graph. Remember that the leading coefficient is the number in front of your highest degree. So we're just going to look at the odd degrees. That would be a cubic, a quintic, x to the 7th, so on and so forth. Linear also. When a is greater than 0, that means positive. Your graph would look like this. If a is less than 0, that's negative, then it would flip. And it would look something like this. This is a quintic. Let's talk about the end behavior. So on the left function here, the graph falls to the left and rises on the right. Well, how would we write that in function notation, in mathematical notation? F of x will represent the graph. F of x goes down. What's down? Negative infinity. So on the left side, f of x goes to negative infinity as x goes to negative infinity. Because you're talking about the left side anyway, that refers to your x values. On the right side, so again, since you're talking about the right side, then your x is going towards the right, positive infinity. What's your graph doing? It's going up. So f of x approaches positive infinity. Okay, let's take a look at the right side, the right graph. On the left, the end behavior, f of x is going up. So f of x approaches positive infinity as x approaches negative infinity, because you're talking about the left. On the right side, f of x is going down, negative infinity, as x approaches positive infinity. Okay, let's take a look at degrees that are even degrees. When a is positive, you all know that it's happy face. If a is negative, it's upside down. So what's the end behavior here? The graph f of x is going up. So f of x is going to positive infinity as x approaches negative infinity. And again, since you're talking about the left, then x will be going to negative infinity. On the right side, f of x goes to positive infinity as x goes to positive infinity. Okay, now let's look at when a is negative. On the left, the end behavior on the left, your function is going down negative infinity as x goes left. On the right side, your function is going down as x approaches positive infinity. Because again, you're talking about the right side. And remember, these end behaviors will be true for all even degrees, depending whether it has a positive leading coefficient or a negative leading coefficient. So now let's practice some. Take a look at this one here. What is the leading coefficient? Make it smaller. Negative. What's the degree of the function? 4. So this is a quartic. The best thing to do here is if you sketch the graph would look like an M. And let's go ahead and find the left hand and right side behavior. So on the left side, what's going on? Your function is going down as x is going to the left, because you're talking about the left. What about the right side? Your function is going where? Down. And since you're talking about the right, your x is going to the right. It's going to the positive infinity. Okay, try this one on your own. All right, what is the degree of the function? 5. It's an odd number. What's the coefficient? Also 5. It's positive. So the graph would start from the bottom left, and remember it has 5 directions, so it goes up 1, down 2, up 3, down 4, up 5. End behavior on the left-hand side. F of x approaches negative infinity as x approaches negative infinity. On the right, f of x approaches positive infinity as x approaches positive infinity. Okay, what about this one? So, same idea, except for it's negative. It's flipped. Like that. F of x approaches positive infinity as x approaches negative infinity. So the graph is going up as your x is going to the left. What about the right side? F of x is going down, that's negative infinity, as x approaches positive infinity, it's going to the right. All right, why don't you guys take the rest of the period to work on your assignment, practice, and behavior, so that when I come back tomorrow, we can go on forward and start solving these and we're able to sketch them. All right, have a good day. See you tomorrow.